Hello, this is Mr. Huber. In this lesson, we're going to continue looking at function operations, and this time, compositions of functions. Compositions is composing two functions together, so working with them within one another. The way that this is written as a composition, you can see here two functions. So we've seen functions before like g of x, f of x. Now we're seeing a function inside of another function. Composition can also be written this way, where there's an open circle here between the f and the g for the two functions. Different than a dot. When there's a filled in dot, it's multiplying. These are both read as f of g of x. We know this right here, this part is just to be g of x. Now this is f of g of x, or f of g of x. So it's a function inside another function. Right here we would take the x and put it into the function g, whatever the g of x is. And then now we're going to take this whole g of x value and plug it into the f function. So when you are working with compositions, you want to work inside out, or in this case, the function closest to the x or the value first, and then out away from this input. So we're going to take the input into the first function, then that value into the second function. So when we see these, we're going to be computing one function value and then taking that result and putting it into the next function. Okay? So we see here, first find the value of the function g of x in those examples, and then whatever we get for that value, we take that and plug it into the f of x function. So in these examples, we're not plugging a 5 into g and f. We're going to plug the 5 into the g of x function, get a value for that, and plug that whole value into the f function. So let's see these examples. First, we're going to find g of 5. So g of 5 means we're going to take a 5 and plug it into the g of x function. So 2 times 5 squared. 5 squared is 25 times 2 is 50. So now we're going to take this value of 50. G of 5 is 50. So now we're doing f of 50, because g of 5 has a value of 50. So now we're going to take f of 50, not 5, 50. Let's change that here. F of 50, and that's going to be 50 minus 8, because we're using these functions up here. So for f of 50, we're putting a 50 into the function, minus 8. That gives us a final value of 42. Okay? That's the value of f of g of 5, is 42. So you're going to find the inside function value and then plug it into the outside function. So if now in the next example, we're going to find f of 5. So f of 5 is equal to 5 minus 8, which is negative 3. So that means now we're going to take g of negative 3. And that's 2 times negative 3 squared. Negative 3 squared is 9. Positive 9 times 2 is 18. So that would be our function value for this composition, g of f of 5. Again, we start with the inside function, get that value, plug it into the outside function. Here we're not plugging in a numeric value, we're going to plug an a into that f function. So we're taking an a and we're going to plug it in here where the x is. Just like when we did g of 5, we took a 5 and plugged it in for the x. F of 5, we took a 5 and plugged it in for the x. Now we're going to take this a and plug it in for the x. So we're going to have f of a is equal to a minus 8, which means now we're going to do g of a minus 8. So we're going to take 2 times, we're replacing the x with a minus 8. So we replace this x with whatever value we have here, a minus 8. So we're taking a whole polynomial, 8 minus 8, and putting it in there for x. And we have to square that first. So when we square the a minus 8, that's going to be 2 times, you're going to have to FOIL this, and check and make sure you're foiling that correctly. You should get a squared minus 16a plus 64. And then now we can multiply all that by 2. Just like we did over here. We did negative 3 squared was 9. Multiply the 9 times 2. We do a minus 8 squared, and we multiply that all by 2. So that means I'm going to take the 2 and distribute it and get 2a squared minus 32a plus 128. And that would be our final answer. It's not a numeric value like 42 or 18 in the first two problems, but we're going to get a value for g of f of a. In the next example, we're seeing f of 3. So we still work with the inside function first. We're going to find f of 3. So f of 3 is 3 minus 8, which is negative 5. Now we're going to find f of negative 5. So we found the f of 3 value, negative 5, and then we're going to plug that into the f function again. So we still work our way inside out. We're taking the f of 3, getting that value and plugging it back into the f function again. So it's negative 5 minus 8, which is negative 13. So you can compose a function with itself. Before we see a few more examples of compositions, a little musical interlude here to break things up. What was the first #1 song on the Billboard Top 100 charts? The very first song in the Billboard Top 100 was Poor Little Fool by Ricky Nelson. The Top 100 debuted in 1958, and that song stayed on the top of the charts for only 2 weeks, but hey, 2 weeks longer than any song I've ever had, so congrats to Ricky Nelson for being the first song on that Top 100 chart for a couple weeks. All right, now let's see compositions of functions, where again, we're not getting a numeric value, but we're going to plug in a whole function into another one. So in this example, we're seeing f of x. We're going to take f of x and plug it into the g function. Well, we have f of x here. F of x is equal to 2x squared. So if f of x was equal to 3, we'd replace the x with a 3. If f of x was equal to negative 8, we replace the 3 with a negative 8. If f of x is equal to 2x squared, we're going to take that 2x squared and put it in there for x. So we're going to have g of f of x means we're going to have 3 times 2x squared plus 4. Okay, we took this function here and we replaced x with 2x squared. Replace the x with a 2x squared. And now I can multiply that by 3 and get 6x squared plus 4. That would be my composition of the two functions. In the next example, now we're going to take the g function and plug it into the f function. So we're going to plug the g function into f. That means we're going to go reverse that direction here. We're going to take 3x plus 4 and we're going to plug it in here for x. So what's that going to look like? It's going to look like 2 times 3x plus 4 squared. Right? Instead of 2x squared, it's 2, and then the function g of x, 3x plus 4, squared. So we're going to have to square a binomial here properly. It's going to be 9x squared. And you get the two middle terms that will combine. You'll have a 12x and a 12x. That's where you get the 24x. Foil these to make sure that you are able to square that binomial, 3x plus 4 times itself. And now we can distribute the 2 into the parentheses, and we'll have 18x squared plus 48x plus 32. And that would be our composition of f of g of x. All right, a couple other examples that will bring up some different situations here, like with an x minus 3 over 2 and things like that. So now we're going to take the g of x function and plug it into f. So that's going to give us, we're replacing this x with 4x plus 5. We're taking g of x and plugging it in here to the f function. So we're going to end up with 4x plus 5 minus 3 all over 2. That's going to be 4x plus 2 all over 2. And since I can divide each of those by 2, we can do that, and we'll get 2x plus 1. In this next example, we're going to take the f function and plug it in to the g. So now we're going to have 4 times x minus 3 over 2 plus 5. And again, we took this whole function f and plugged it into the g function for x. So now, when we simplify this, this is like 4 over 1. Those can reduce to 1 and 2. So we're going to multiply the 2 into the parentheses and get 2x minus 6 plus 5, which equals 2x minus 1. So I know how to work with these different binomials, squaring them and different things with the foiling. Here we're doing different polynomials and fractions and plugging in whole values of functions into other functions. Right? So we're going to practice those, make sure how to work with different things where we're multiplying and adding and subtracting with like terms, some of those different operations we've seen with polynomials, and now how it works with what's a composition and how those can be written and what that looks like, how to work with something that looks like this: f of g of x, g of f of x, know what it's written as, what it sounds like when you say it, what it looks like when you plug values into functions, and then continue on to the next composition.